Hi, this is Mr. Parks, and today we are going to go through the review together. Pay attention and let's do it. The first skill you will need to be responsible for is end behavior. And the way you read this, the first part says as you go to the right, and then down here where it says negative infinity, that means as you go to the left. So as you go to the right, as you go to the left, as you go to the right, as you go to the left. Sounds like I'm rapping. This is a mistake. This should be negative right there, not a positive. So let's see. As you go to the right, the function goes up. As you go to the left, the function goes down. That's what that says. So I read that as up and up, down and down, down and up. So let's see. This is the right side. It is going up. On the right, it's going up. And then it comes down. Can't see that part. And then it goes back up. So I need the one that says on the right it goes up and on the left it goes up. Let's see. Right here, B. On the right it goes up, on the left it goes up. Now the second question is this even or odd degree? Even degrees do the same thing. So they'll be either both go up or both go down. Odd will do the opposite, down, up, or up and down. So because both of mine are going up, this is actually a really easy question. This is of even degree. And then finally, what could this function be? Right here, I have -4. Uh-oh. So that could be x plus 4. And it'd be x plus 4 to the first power because it goes straight through. And then right here, at this point, that is 3, so I'd make x minus 3. And again, to the first power, because it goes straight through. Here, though, I have what's called a bounce. So it comes down, touches, and goes back up. It doesn't go through. So remember, that has to be of at least degree 2. Could be degree 2, 4, 6, or 8. Let's just go with 2. So that would be x minus 4. But it has to be to the second power. So putting all that together, P of x would equal x plus 4, x minus 3, and x minus 4 squared. Now when I look at this, I have 1 x plus 4, 1 x minus 3, 2 x minus 4s. So you add the exponents, that'd be 4. So that would be degree 4, which I bet it would look the same. Let's go look. So let's go type this in and check my work. X plus 4. Since I add on an x minus 3, it turns into a parabola. And then I add on the x minus 4 squared. Oh, squared. And there we go. Looking at those, they look pretty much identical. That's good. Sometimes you need to put a number out here to like stretch it or compress it, see? But we're not going to mess with that, okay? So we're good. And I just realized we forgot to list the zeros. The zeros were -1, 3, and 4. Excuse me. I remember 4 has multiplicity of 2. That means it happens twice because of the bounce. Okay. -1 and 3 those have multiplicity of 1. Okay. There we go. So 3 zeros. Next, let's do it. So I have this one, which I almost said was -2, but it's counting by 2, so that'd be -4. So I got -4. And then I have this one, which looks to be at 2. And 2 has a multiplicity of 2. And -4 has a multiplicity of 1. In other words, it happens once. So this would be x minus 4 to the first power for this 0 right here. And this one, that'd be x minus 2 to the second power. Go ahead and put all that together. P of x would be x minus 4 and x minus 2 squared. And order doesn't matter if you want to put the x minus 2 first or the x minus 4, but the exponent, where that goes, does matter. So let's check our work. X minus 4 and x minus 2 squared. Ooh. Oh, it's almost the same. I need to turn this thing upside down because it's going down on the right. And when I keep this positive, it always goes up on the right. So I need to put like a negative out there to kind of flip it over the x-axis. So let's do it. There we go. Oh, another mistake. This is minus 4. So that should say x plus 4 for the factor. So that should say x plus 4. See? This is why you check your work. There we go. It bounces at 2, comes through at -4. Bounces at 2, comes through at -4. Now, is this of even or odd degree? Let's look at the end behavior. It looks like it goes up over here. And it looks like it goes down over here. So it's going on the right, it's going down. So on the right, it's going up, new. On the right, it's going up, new. On the right, it's going down, yes. So we want the one that says this. And then on the left, it's going up. On the left, it's going down, new. On the, and again, like I said, this should have been a negative. On the left, it's going up, yes. So the answer would be D. And because we have one going up and one going down and they're not the same, remember those mean odd degree. Okay. I almost have too many of these. Number 3. I have -1 and I have 2. Okay, those are my zeros. -1 and 2. Now 2, because it does what's kind of like a squiggle, that usually means multiplicity of 3. I can't spell that word, obviously. And -1 goes straight through, so that's multiplicity. Ooh, I spelled it, of 1. So if that's x minus 1, that'd be x plus 1 to the first power. And if this is 0, if the 2 is a 0, it'd be x minus 2. And it's a squiggle, so I'd put to the third power. Putting all that together, I get P of x equals x plus 1 and x minus 2 to the third. Now, notice this goes down on the right, so I need to put a negative sign out front to flip it over. So let's go double check. Negative x plus 1, x minus 2 to the third. Oh, x plus 1. And x minus 2. I don't know where I got all that from. There we go. So notice they are pretty much the same. Okay. Now let's talk about the end behavior. On the right, it goes down. So I need the one, this is right, right, right. On the right, it goes down. I need negative infinity, so it could be this, or it could be that. And then also on the left, it goes down. So this is left. I need the one that says down or down. So looks like it has to be C. Now this would be of even degree because they're both going down. All right, number 4. What are the zeros? The zeros would be 1, multiplicity once, and 5, multiplicity 2 because it bounces. So I'd say 1, multiplicity of 1, and then 5, multiplicity of 2. So if that's 1, that becomes x minus 1 to the first. And if that's 5, that becomes x minus 5. And it's a bounce, so you put the 2 on there. That's how it bounces. Now it's going up on the right, so I don't need to flip it over. So it'd be equals x minus 1, x minus 5 squared. Go check it out. Yep, looks good to me. And then we'll do the end behavior. This looks like on the right it's going up, on the left it's going down. So on the right going up, on the left going down, that'd be A. And because I have one going up and one going down, that has to be odd degree. All right, these are a little bit easier. So the key here, and we'll just go through them all one at a time. You take your highest exponent, and by the fundamental theorem of algebra, that's how many total zeros there are. And this isn't always written in standard form. It's not always in order from highest to lowest, but total zeros would be 4. And I'll do these other 2 in a second. Total zeros, you know, it's tempting to look at the first term, but in this one, the highest exponent is 5. So by the fundamental theorem of algebra, there are 5 zeros. Here, highest exponent is 3. So total zeros, 3. Highest exponent, 3. Total zeros, 3. Okay. All right. Now, another key is those 2 numbers have to add to the total, because this is total, and the solution is either real or non-real. So these 2 better add up to 4. And furthermore, non-reals always come in pairs. So if you put like the answer 1 here, that can't be true because non-real always come in pairs. So this always has to be 2, 4, 6, 8, and so on. So let's go graph it. So I zoom out, see that? And I see I have 1, 2 solutions. So that'd be 2 real solutions because I can see those. So this one would be 2. And then the 2 you can't see would be non-real. And notice 2 plus 2 is 4.